Hello everyone, my name is Nikhil Gupta and today I'll be talking to you about forecasting the next recession. Our team consists of Stuart Miller and myself. By some definitions, a recession is defined as 2 consecutive quarters of GDP decline. So we are going to build a model to predict the GDP for the next 2 quarters. Our dataset consists of GDP for the USA from 1971 to 2019. We also collected 13 exogenous variables, but for the purpose of this presentation, we're going to focus on the univariate analysis. Before going on to the model development process, let's look at the stationarity. Looking at the realization, we see there's a slight downward trend in the data, and we also see from the spectral density that there's a peak at f equal to 0, hinting towards wandering behavior. The ACF also shows slight hint of extended autocorrelation. All these point to a non-stationary process. Looking at the variance, we only have one realization, so it's a little hard to say whether the variance varies with time. But if you look at the first half and the second half, we find that the first half has a much higher variance compared to the second half, again hinting towards a non-stationary process. Looking at the third condition, comparing the first half and the second half ACFs, we find that they are actually quite different. And again, this is pointing towards a non-stationary process. So in conclusion, this is most likely coming from non-stationary process, but as a counter argument, we can also say that the GDP of a developed country should be pretty stable over the long run. So we can also model this as a stationary process. So we're going to build both these models and compare the results. So we started off building models with lower ordered P and Q terms, but we found that the residuals were not white noise. So hence we increased the order and we found that the ARMA 13.1 was a good fit. It had an AIC of 2.3 and the factored model is shown here. It has a white noise variance of 8.56. We also find that one of the factored terms is very close to the unit circle, similar to what you would find from a non-stationary model. Similarly, on the ARIMA, we fit ARIMA 1110 after difference in the data once. The AIC for this model was 2.33 and the factored model is shown here. It had a white noise variance of 9.05. Looking at the residuals, we find that they are actually quite consistent with white noise, and even the Young box test fails to reject the null hypothesis. Looking at the forecast for the rolling window, we find that neither of these models does a very good job at predicting sharp dips in GDP, and we find that the ASC value actually increases quite a bit whenever there's a sharp dip in GDP value. Looking at the ASCs across the different batches and comparing them statistically, we find that there is no difference between the two models statistically. The p-value is 0.685, although the ARMA model has a slightly lower mean compared to the ARIMA model. Now, since both these models are not doing a very good job at predicting the GDP, our next steps are to add exogenous variables and hope to improve the prediction power of these models. See you next time.